some important parts of a lens. Center of curvature. Students, it is the center of the sphere where the surface of a lens forms a part. As a lens is usually bound by two spherical surfaces, there are two centers of curvatures, represented by C1 and C2. Principal axis. The line joining the two centers of the curvature C1 and C2 of the surface of a lens is called a principal axis. Optical center. The center of the lens is called its optical center. A ray of light passing through the optical center of a lens does not bend after refraction. In the figure, the optical center is shown as O. Principal focus. When parallel rays of light fall on the surface of a lens parallel to the principal axis, the rays after refraction through the lens coverage to a point, that is convex lens, or appear to diverge from a point as in concave lens, this point is called the principal focus. As light may pass through either side of the lens, there are two principal focuses on either side of a lens. For convex lens, the rays after refraction actually meet at F as shown in the figure, so the focus of convex lens is real. For concave lens, the rays after refraction becomes divergent and when produced backward appear to come from F as shown in figure, so the focus of concave lens is virtual. Focal length. The distance between the optical center and the principal focus of a lens is called the focal length. It is denoted by F. The focal length of convex lens is positive. The focal length of concave lens is negative. Method of determining the focal length of a convex lens. Now look at this activity. Students, take a convex lens and hold it with one hand. Keep a sheet of white paper at a distance 25 cm from the lens. Now move the lens to and fro from the paper in order to get the clearest and sharpest image of the distant objects like trees and buildings on the paper. When this condition is achieved, measure the distance between the paper and the lens with the help of a meter scale. This distance is equal to the focal length of the convex lens. Students, the process of adjusting the distance between the lens and the screen in order to obtain a clear and sharp image of an object is called focusing. If the above activity is repeated for a thin and thick lens of the same diameter, it will be clear that the focal length of a thin lens has a longer focal length than that of the focal length of the thick lens.